Greetings, Algebra 2. Today we're going to spend time reviewing the key topics from Semester 2 as a way to review for the final assessment. You'll want to have your notebook nearby in case you need to reference any previous notes or to make any notes in there about what you need to study going forward. All right, let's take a look at quadratics. So when we were in the quadratics unit, we had three types of quadratic functions. The way we wrote them out, we either had vertex form, we had standard form, or we had intercept form. So we're going to take a look at two of those. And in this case, I have a vertex form. It's called vertex form because I see the vertex built in. I see that my horizontal shift is 1 and my vertical shift is -2. So a couple of questions we can go through and just answer right away. I know this is going to open down because it's a negative function. I know I have an axis of symmetry at x equals 1 because that's where my horizontal shift, goes. If I'm going down, that means I'm going to have a maximum. It's going to be at my vertex, which I know my vertex is also going to start with a 1. I can see that my vertical shift is down 2, so my vertex is actually at 1, -2. My domain, if I'm dealing with a parabola, u's go forever left, forever right. If it's going down, then I know I'm starting at negative infinity and I go up to that y value of -2. So y's versus x's, remember that. My intercepts, I can always find my intercepts. If I want to find my x-intercept, then I want to know my x, so I plug 0 in for a y. If I want to find my y-intercepts, then I plug a 0 for x to find my number for my y's. So that's going to take a little bit of work. So let's come up with a few more values here. I'm going to plug in values around this. That's one option you could do, and then you can plug them in and see what you get, whatever those numbers are. We also dealt with the shifts, so we used a parent table. So the parent table occurred starting at 0, 0, and then we said 1 squared is 1, and then we said 2 squared is 4. And then if I go the other way, -1 squared is 1, and -2 squared is still +4. And then we applied our shifts, and we said a negative out front, so -1 times -1 times every y value, because that is my vertical stretch or compression, so it affects my y's. I have a +1 to affect my x's. And then I also have a -2 affecting my y's, so I'm going to subtract 2 from the y's. So we use the parent table. There are plenty of approaches, but we did parent tables with everything, so it's a little easier to remember. So I've got 3, 2, 1, 0, -1. And then here I'm going to have a -6, a -3, what do we got? A -2, and then -1, -3 again, and a -6 again. So now this makes sense with what I see on my graph. So if I graph these values, I'm at 1, -2, I've got that, -3, -3, and then -6, -6. So I can graph that parabola there. Now, as for x-intercepts now, I know I don't have any visible on the graph, but I still need to solve. So I still need you to plug 0 in for y and solve the equation. So let's start off with the easy stuff. Let's start by adding 2 to the other side. Let's divide both sides by -1. The opposite of squaring is square rooting. If I square root a -2, I have to take an I out. And then I'm going to add 1. So I'm going to have 1 plus I radical 2 equals 0. Now I square rooted. This doesn't seem right, right? I feel like I'm missing something. I should have 1 plus or minus. Okay, anytime you take an even root, you got to have that plus or minus. So this is what I have for my x-intercepts. My y-intercept, don't worry, is way easier. I'm just going to plug 0 in for x and solve. So I end up with 0 minus 1 is negative 1, negative 1 squared is 1, put a negative out front, negative 1 minus 2 is negative 3. Oh, wait a second, I already knew that because of my table. Increasing interval, I'm increasing, those are my x values from negative infinity on the left side, I increase all the way to the x value of 1. And then I am going to decrease from that 1 value all the way to infinity. And I forgot one thing in this problem here. So let's take a look. My range needs to have a bracket. Okay, I'm including that negative 2 in the range. So make sure you have that bracket. All right, let's take a look at another one. Now in this case, I have intercept form. I know it's intercept form because I have two x's that are spread out. And if I'm looking for my x-intercepts, so I'm going to jump straight down to that. To find x-intercepts, I plug 0 in for y and I solve. Well, if I plug 0 in for y, this looks like a factored equation. So I set each piece equal to 0. Oops, equals 0, equals 0. 2 can't equal 0. If I set this one, I end up with x equals negative 2 and x equals negative 4. So my intercepts, if I write them out, are negative 2, 0 and negative 4, 0. So now you can see why that's called intercept form, because those intercepts are very easy to see. So I've got a negative 2 and a negative 4. So plot those right away. Start there, which then tells me, hey, the middle value between there becomes my axis of symmetry. So my axis of symmetry is going to be x equals negative 3. It's a parabola, so let's fill in the domain right away, negative infinity to infinity. This is a positive function, so it opens up because my leading coefficient is positive. My vertex, I know it's going to occur somewhere at negative 3. I got to find the rest of it yet. Max or min, if it's going up, it's going to have a minimum, and it's going to occur at that vertex that I need to find. My range, I still have to find my y value. I can't do that yet. My y-intercepts, let's calculate that quick. That means plug 0 in for x and find y. So if I do that, I have y equals 2, 2, and 4. I end up with 8, 8 to 16. Write it as a point though, so 0, 16. So I can't actually plot that, okay, because my graph doesn't extend that far. So I need to find this y value here. No matter what function I give you, no matter what values I give you, you can always find a y value if you know an x value, because all you have to do is plug it in. So negative 3 plus 2 and negative 3 plus 4. So let's simplify that a little bit. I have a negative 1 and I have a 1, so I end up with negative 2. So negative 2 is going to get filled in for all those values. And then my range is going to go from negative 2 up to infinity. And I forgot this on the last slide, I apologize, but this should be a bracket on the range because that point is included. So at negative 3, negative 2, there is my vertex. And then I shouldn't cross the y-axis because it's really steep and it should hit at 16, which we already calculated. Oh, sorry, that's not a very good parabola there. Okay, so now I can talk about increasing, decreasing. I'm increasing from that negative 3 to infinity, which means I'm decreasing from negative infinity to negative 3. All right, let's take a look at reviewing polynomials. This first few review problems, this is Algebra 1 stuff. The second page will be more Algebra 2 content. So we'll go pretty quick through this. If I'm going to add functions, then I just need to make sure, to add like terms. So most students are pretty confident here, but just be careful. I make silly mistakes too. Make sure you write it down correctly. Make sure you're actually adding the like terms. So I should have a 4x cubed plus a 14x squared, but then I have a negative 59x and then a positive 2. Always make sure your answers are written in standard form. All right, if I'm multiplying, if I have a 4x cubed plus a 14x squared minus 60x, and I'm timesing it by x plus 2. You can use the box or distribution. I'm going to use distribution. So I'm going to say x times all three, which gives me a 4x to the fourth, 14x cubed minus 60x squared. Then if I distribute the 2 to all of them, I'm going to line them up. I have an 8x cubed, a positive 28x squared, and a negative 120x. So now if I combine like terms, 4x squared plus, what do we got? Oops, 22x cubed, and then an x squared value, what does that give us? 60, 50, 40, 32, negative 32, and negative 120x. So just double check, we were multiplying, so, oops, this should be a 4, my apologies. Our degree should increase by 1 because we took x cubed times x. And subtracting, the main thing to watch out for with subtracting is that you're subtracting everything to the right or below, depending on how you set it up. So I'm going to have a 2x squared, that stays the same. I have 0x minus 1x, that's a negative 1x or negative x, and 9 minus 2, which give me to 7. Make sure all your answers are in standard form. All right, let's take a look at a few more polynomial operations, and this is where we really get into the Algebra 2 concepts. So the division. If I have a polynomial divided by a polynomial, what I need to probably start with is either synthetic or long division. So you got to remember those rules. If you need extra help beyond this video, know that I have other videos on my YouTube channel to help you with this division. So I'm going to use synthetic division. So as I set that up, it's going to be a negative 2 on the outside, and I need to have every coefficient. And if I'm missing a value, I have to put a 0 in. I'm missing the constant here, so I'm going to put a 0 in. Okay. So now if I bring down the 4, I'd have a negative 8. If I subtract that, I've got a 6. I've got a negative 12. I've got a negative 72. And I've got a positive 144. So now as I read those from right to left, this is my remainder, my constant, my x squared. You should always be 1 degree less. So that's how you sort of know how it lays out. But now I need to actually write my answer. My answer is 4x squared plus 6x minus 72. And then in addition to that, I have a remainder of 144 over the divisor of x plus 2. All right, let's do some factoring and solving, in case we haven't done enough factoring this year, right? So let's take this polynomial. First of all, always check for a GCF. If I can somehow make it smaller, that would help me out a lot. So let's take a 2x out, which gets me to 2x squared plus 7x minus 30. I now need to factor that quadratic into 2 binomials. So I'm going to start with a little bit of side work here. I'm going to have a times c, negative 60, and 7. Think of all the factors of 60, 1 and 60, 2 and 30, 3 and 20, 4 and 15. Oh, can I stop yet? 5? No, not yet. Let's see, 5 and 12. Hey, there we go. 5 and 12 give me a difference of 7 with our signs of a negative 5. So again, I just go through the list. 1 times what, 2 times what, 3 times what. Make that list off to the side. I cannot plug this in, you guys, because I have a leading coefficient. So I need to see that little bit of extra work. A 2x squared, a negative 30, but I also have a 12x and a negative 5x. Group them. I've got a 2x, which gives me x plus 6. I've got a negative 5, which gives me an x plus 6. Perfect. Same thing twice. So my 2 factors are now x plus 6 and 2x minus 5. Now this says factor and solve. Set each piece equal to 0. 2x equals 0 gives me the answer of x equals 0. Right? 0 divided by 2, that matters. X plus 6 equals 0. Subtract 6. I get x equals negative 6. And x 2x minus 5 equals 0, 2x equals 5, x equals 5 halves. Okay, all of these, when you factor and solve, you can plug back into the equation and see if it does give you a 0. So you can always check and make sure you're right. All right, exponent rules. Let's go back to these. This is again some Algebra 1 concepts. I have videos from earlier in the year to help if you need it. But first of all, I see I'm multiplying, so I'm going to take care of that. The order in which you do some of these rules doesn't matter. So you might see a different entry point than how I start. Then try that, please. Pause the video, do what you see first, and then let's compare. So if I multiply across, I've got a 6. When I multiply bases, I add the exponents, so x to the 5th, that's a rule, and y to the negative 2. On the bottom, I've got a 9, an x squared, and a y cubed. Next, I'm going to deal with the negative exponent. So I'm going to actually kick that to the other side, which means now I can combine those. So next step, I'm going to reduce the 6 and the 9. I've got y to the 5th on bottom. Then if I look, I can take care of those x's as well. I have x to the 5th over x squared, so x cubed. So when you divide like bases, you subtract the exponents. So that would be my simplified fraction. All right, let's take a look here. 27 to the 2/3. Remember, e over I is the shortcut you can use. So what this means is, I'm going to break it apart. You don't have to show this, but it means 2 over 1 times 1/3, right? If I split up that fraction. Well, 1/3 becomes a cubed root, and 2 over 1 becomes an exponent. Okay, the cubed root of 27, so what times itself 3 times? Gets me to 27. In this case, 3. So I still have that squared though, and 3 squared gives me 9. Now, yes, I know you're going to have a calculator. You could plug in 27 to the 2/3 and you could tell me it's 9. But I want to see work, and it's a way of checking your answer. So always, always check your answer. All right, let's take a look at some simplifying and solving of exponents, radicals. First thing, to multiply, you just need like indexes, and we just literally multiply the radicands under those like indexes. So I would arrive here at, what do we got? Oops, 54. Let me fix that, cross that off. So I'm at 54, but then I have to reduce. So your perfect roots chart would be helpful. I need a perfect cube that divides into 54. Well, 1 cubed, 2 cubed, 3 cubed, I can stop right there. 27 is a perfect cube, and times 2 would get me to 54. So the cube root of 27 is 3, and then I've got cube root of 2. So that would be my reduced radical. All right, I'm solving for x here. So first thing, this 4th is in the way, so I'm going to do 4th root to both sides because that would be the inverse operation. So I'm going to have an x plus 4 on the left side, but I'm taking the 4th root of 16. Yes, it's 2, but this is an even root, so it's actually plus and minus 2. So when I subtract 4 to the other side, I have negative 4 plus 2 and negative 4 minus 2. So my answer should actually be negative 6, and it should be negative 2, both of which I can check. If I plug that in, negative 6 plus 4 is negative 2. Negative 2 to the 4th is 16. If I plug in negative 2 minus 4, negative 2 plus 4, that would be 2. 2 to the 4th is also 16. So I know that that answer is correct. All right, in order to add or subtract radicals, you need to have the same radicand underneath. So I don't. So that means I need to start off by reducing each radical into what I call a good and a bad. So I know I've got a 9 and a 3 here, which gets me to square root of 9 is 3. And then I multiply what's out front. So we have 6 radical 3 on the left side there. Well, in order to subtract, I'm going to make a guess here. I'm going to guess that this should be 3. So 3 times what gets me to 48? In this case, 16. So if I take a look, that does work out very perfectly, so I'm going to keep that. So square root of 16 is 4. Numbers written next to each other implies multiplication, so I have 12. Now I can subtract. So here I'm checking, do you understand that you subtract the numbers out front and keep the radicand, the like radical? Again, just remember, if this is a 6x minus a 12x, we would get a negative 6x. The x didn't change. So if the x doesn't change, the radical doesn't change. You keep the like radical. All right, here I'm solving, so I need an x equals value, but that radical's in the way right now. So the opposite of square rooting is squaring. Okay, if I square a square root, that goes away. So that helps my right side. If I look at my left side, squared means the same thing twice. Do not ever, ever distribute. Never distribute onto binomials. Okay, I can't stress that enough. Think of what squared means. It means twice, so write it twice, because when you see that, oh, I've got to FOIL or distribute or use the box. So we end up with x squared plus 4x plus 4. Well, hey, now I got these like terms I can start moving around. Let's subtract that 2x from both sides and subtract this 7. So I have an x squared plus 2x and a negative 3 equal to 0. Hey, that looks pretty handy. Leading coefficient of 1. Let's factor. All right, I've got a 3 and a 1. It's going to be a positive 3 and a negative 1. If I set each factor equal to 0, I can solve. X equals negative 3 and x equals 1. I can still check my answers. If I plug in negative 3 plus 2 is negative 1. Oh, wait, negative 3 times 2 is negative 6. Negative 6 plus 7 is 1. Square root of 1 is 1. Is that a true statement? So remember, this is where we have extraneous solutions, anytime you have a radical. So in this case, I have to go and cross off. X cannot equal negative 3. Let's try 1. If I plug 1 in, 1 plus 2 is 3. 1 times 2 is 2. 2 plus 7 is 9. 9 with the square root is 3. So the 1 is my only true solution. All right, graphing square roots. First of all, let's identify our parent function. So our parent function is just the square root of x. So let's make a table for that. Okay, if I make a table for the square root of x, then I want perfect squares. Well, 0 square rooted is 0, so that's a good number to pick. Let's see, should I do negatives and positives? Well, wait a second. If I try to pick a negative, I can't square root a negative. That's no good. So a 0 is actually going to be my starting number, which means I only want positive numbers beyond that. So let's do 0, 0 here. If I choose 1, square root of 1 is 1. Okay, I'm doing the parent table for square root of x. If I plug in 2, square root of 2 is some crazy decimal. No good. So I'm going to jump to 4. The square root of 4 gives me 2. The square root of 9 gets me to 3. I've created my parent table, so now I need to look at my moves. I've got a 2, a 3, a 5. Let's read left to right. The factor, the leading coefficient, is times my y values. That is my vertical stretch or compression. The plus 3 is an x value, and so we're going to subtract 3 from all x values. Remember, we do the opposite sign there. And then the outside number is my vertical shift, so the positive 5 shift. Okay, so now if I create my actual table, it's going to work out a little bit nicer. Now remember, square root functions should look like a shooting star, some form of that. It can be flipped all different ways around. Okay, so we've got 6, 11. So let's see if it looks the way it should look. Negative 3, 1, 2, 3, 4, 5. Negative 2, 7. 1, 9. And 6, 11. 1, 2, 3, 4, 5, 6. And just off the graph. So if 0, 0 is my starting, then negative 3 is the start of my shooting star. So I shoot up. Remember, it looks like half a parabola, half a u, because they're inverse operations. Okay, So if it doesn't look like that, don't leave it. Tell me it should look like what it should look like, so that I at least know you understand that. If your graph doesn't turn out the way it should, say it doesn't look right, then at least I know you recognize that. Some students also, yeah, you can check in your calculator. They've looked in their calculator, made sure they're right. That's great. You can do that. I still need to see the work to go with it. So you can't just plug it in and graph it. I need to see a little more than that. All right, let's get into the most recent stuff. This should go the quickest because it's the most fresh on your mind. Let's rewrite an exponential form. The base becomes the base. The answer becomes the exponent. What's remaining becomes your answer. Let's go the opposite way. The base becomes the base. The exponent becomes the answer. What's remaining becomes your main value. So all of these you can check in your calculator. Plug them in, make sure it's right. Use a calculator to evaluate. So you guys have the option. I'm not going to write out the decimal here because I actually don't have my calculator with me. But you have the option. If you're using scientific, log base 7 divided by log base 4. So let's change the base. Or if you're using one of the graphing calculators, you can fill in the boxes of 4 and 7 and tell me what that approximate value is. Remember to round. You've got, after your decimal, you've got tens, hundreds, thousands, 10,000s. Make sure you know how to round. Expanding and condensing. So we're just quizzing on this still, so it should be very fresh in your mind. I have 3 pieces of information, so I should have 3 logs. Okay, each piece of information gets its own log, and then exponents become numbers out front of what they're affecting. So the 3 is only on the y, so the 3 only goes on the y. And then what goes in between? Well, we're multiplying, so that changes to adding. Okay, condensing, let's do the reverse. So now numbers out front become exponents. So I'm going to write that first. I'm going to show a few steps. Log base 4 of x squared minus log base 4 of n cubed. Subtracting becomes dividing. So I want 1 log base 4. What comes first is in the numerator. What comes second is in the denominator. So that would be my condensed expression. All right, let's take a look at some exponential word problems. So first of all, I gave you the compounding formula, so you really have to go through and identify your key information. So quarterly means that my end value is going to be 4. My 1,500 is what I invested, so it's my principal amount. 6.4 is my rate, and I'm looking for the value after 4 years, which would be time. So if I plug that in, that would mean I'd have 1,500, 1 plus my rate of 0.064, remember that conversion, over 4, and all of that's going to be to the 4 times 4, because quarterly and 4 years. So I would break it up piece by piece, okay? Let's take care of what's in parentheses first. So in my calculator, I type in 0.064. I divide that by 4 equals, and then I add 1. So you should get 1.016 to the 16th. Now there's just a little less parentheses I might need, a little less errors as far as typing into my calculator. So in this case, we arrive at 1,933.71. We're going to round. It's money, so 2 decimal places. And that makes sense. So 1,500 bucks, I grew by $433 after 4 years. That makes sense. All right, exponential growth and decay models. The population of the People's Republic of China was 1.273 billion in 1991. It grows at a rate of 1.5. In what year was every year, sorry. What was the population in 2009? So if I identify my information, this is my starting value here. I've got a rate here. And my time is from 91 to 2009. So you don't put 2009 in. You're going to subtract those two or find the difference, whatever's easiest for you. But my time is actually 18 years. So if I plug that in, what's the population? If I start with 1.273 billion And I'm starting with that, and I'm increasing by 0.015. And what would it be in 18 years? So be very careful how you type this in. Watch your decimals, watch your parentheses, and so on. Let's see. So I end up with approximately 1.66424. Now, all of this was billion, so you don't have to move the decimals a bunch. I'd be okay if you just said 1.6 billion, because that's how they labeled. Well, actually, they had 3 decimals, so maybe we should say 1.664 billion. If you're not sure how to round, look at how the problem round. But you could also write it out. So 1 billion, 664,244,629. I would accept that too if you chose to write it down, but no matter what, you need to label people or population or some kind of identification of what it is about. All right, let's take a look at a couple more word problems here. I've got a silver Escalade for 63,000. Nope, I would never have that because my teacher income wouldn't allow me to spend that much. But let's pretend that I'm rich and can buy a nice Escalade. Depreciates is a keyword. That means subtraction, and I have my rate. So write the exponential model and find the value after 6 years. So my initial amount, 63,000. I'm depreciating by 0.23. What is it worth after 6 years? So be very careful with parentheses. Really, this ends up just being a calculator problem in the end. So it would be worth, looks like $13,130. Okay, so wow, that depreciated quickly because 23% a year, that is a quick depreciation. So this makes sense. If you did cents, I would do 61 and round that up. When will the value be 30,000? Well, it's going to be less than 6, so somewhere between 0 and 6 years, because after 6 we're at 13,000. So 30 is not a very far dip. So 30,000 is where we end up. We still start with 63,000. We still have the same rate, but the difference is I don't know my time. So let's divide both sides by that 63,000. Okay, do the simple math first. This is simple math. Okay, 30 over 63, you could take that down to 10, and we've got 21 equals, let's take care of 1 minus the 0.23. That would give me 0.77 to the t. I can't solve an expression the way it is, so I am going to convert. If you can't solve an exponential, convert it. Try it. Trial and error is okay. The base becomes the base. The exponent becomes the answer, therefore what's remaining becomes your main value. So at this point, be careful if you so choose to use change of base. If you use the log button in your calculator, then it's a lot easier. You can just type in the 0.77. You can type in the 10 divided by 21, and we should end up with t is approximately, I've got 2.8. Doesn't tell me how to round, but I would label 2.8 years. And that makes sense. Please don't leave an answer that doesn't make sense. All right, let's take a look at some exponential functions, do some solving on all of these. Do the easy stuff first. So the easy stuff is subtracting 6 from both sides. I can't solve it, so I got to convert it. E becomes ln. The exponent becomes the answer. What's remaining becomes your main value. So let's type in, we're going to take ln of 5, and we're going to divide by 2. So we end up with x is approximately 0.8047. If I don't tell you how to round, you can decide, but make sure you round correctly. Easy move here on the bottom left. Let's subtract a -3, which means add 3 to the other side. Okay, then I need to divide by 7. I need to isolate the log. So I've got 18/7. I'm just going to leave it as a fraction. I can't solve that as is, so now I'm going to convert. So the base becomes the base. The answer becomes the exponent. Therefore, what's remaining becomes your answer. Let's plug that into our calculator. 5 to the 18th divided by 7. we get approximately 62.7121. Easy moves first. Add the 9. So I get 19. I can't solve, even though I've isolated. So I got to convert. The base becomes the base. The exponent becomes the answer. What's remaining becomes your main value. I'm going to use the log key on the calculator under math, because I'm using a graphing calculator, or you could do change of base formula. Okay, so I've got a 7 for my base, log base 7 of 19. Find that, and then divide by 2. So solve, then divide by 2. So x is approximately 0.7566. All right, again, easy moves first. Subtract the -4, meaning add the 4 over first. Okay, divide both sides by that -2. Now I've isolated the natural log. ln becomes e. Okay, the answer becomes the exponent. What's remaining becomes your main value. You've got that e button available on your calculator, e to the 5th. Solve that, then divide by 2. And we get x is approximately 74.2066. All right, everyone's favorite, exponential functions, and we're going to graph them. All right, we got to start with our parent table. Look at all these moves I have on this one, first of all. Take a look at that. -2 out front, a +3, a +3. Those are all moves. So let's start with my parent table and function. My parent function is 2 to the x. If I start with my parent table, I'm going to have, oh wait, what am I going to have? When we have these values, there's no, hey, you should always use these numbers. You can start with these x values, the standard x values, but then I have to do a little bit of work. I need to actually find what is 2 to the -2. So I'm going to do some work before I get to my y values. So 2 to the -2. Flip to the bottom, 2 squared is 4, so this should be 1/4 as my y value. And if I take a look, 2 to the -1, I'd flip it, it would become 1/2. So 1/2 becomes my y value. All right, 2 to the 0, anything to the 0 power, that's your freebie is 1. 2 to the 1 is 2, and 2 squared is 4. So remember, you should only have 2 values that you actually have to do a little bit of work. But now let's apply our moves. -2 out front times -2 on your y's. Okay, then you've got a +3 with your x. So I'm going to subtract 3 from all my x's. And then I have a +3 as my vertical shift. So let's add 3 to my y values. All right, let's make a final table here. Okay, -2 minus 3, -1 minus 3, 0 minus 3, 1 minus 3. Kind of nice how this works out. X values are nice and linear. 1/4 times -2 would be -1/2. -1/2 plus 3 would be 2.5. Use your calculator. Feel free to use decimals here. I'm not worried about that. I'm worried about you getting the right graph. Half of -2 is -1. -1 plus 3 is 2. 1 times -2, -2 plus 3. 2 times -2, -4, -4 plus 3. 4 times -2, -8, -8 plus 3, -5. So let's take a look at what this looks like. -5, 2.5. 1, 2, 3, 4, 5, 2.5. -4, 2, -4, 2. -3, 1. What do we got? -2, -1. And -1, -5. Okay, so I can kind of see that curve, right? All these curves looked like exponential growth or decay flipped some way or another, but they were kind of those curves that went into the corner. So I can kind of see where I should go, but let's answer a few questions first. So my parent function, we identified that as 2 to the x. My asymptote is always y equals the vertical shift. So whatever number is being added or subtracted on the end. So I'm going to graph that. Oops, I should say shift. So at 3, I have a dashed line. That's my asymptote. which means I can't cross it right now. So that tells me where this graph goes. It shoots off to the left after I graph my point, and then it goes down. Okay, my domain, I'm going forever left for sure, and I'm actually going forever right. It just doesn't quite look like it, but I am, slowly but surely. My range, I'm starting at -infinity low to high. I'm going up to 3, but I don't include it because it's an asymptote. Okay, so that 3 should show up several times. All right, last few are going to be super quick because we've been doing this for the last week and a half. Simplify, which means I just need to start off by factoring that out. So I've got an x plus 5. I need to AC this denominator, meaning factor it into binomials is my goal. If I use the AC method, it's still called factoring. AC is the method in which we factor. So a times c gets me to 15, 16, which gives me a 1 and 15. That's kind of nice and easy, but you've got a leading coefficient of 3. So show your grouping step if you're not comfortable with the guess and check. Group it out. I've got an x with a 3x plus 1. And if I take a positive 5 out, I've got a 3x plus 1. Perfect. So my factors are, I'm going to jump ahead here. I left it a little unfinished. 3x plus 1 and x plus 5. If I look, factor, factor. Factors can cancel, terms cannot. So this is as much as I can do. Multiplying and dividing, well, they're the same thing. It's just when you're dividing, you should probably flip first. So I'm going to rewrite this first fraction as 2 factors because I know I'm going to have to factor. Multiply, and then I'm going to flip. And I'm going to factor right away. I notice I'm going to have a GCF out of both of these. So let's take care of that right side first. GCF's easier. So a 3x out of here, which leaves me with an x minus 2. And then an x squared out of here, which leaves me with an x plus 4. Okay, so I flipped it, and then I'm doing the factoring. Here, leading coefficient is 1, so that's handy. Factors of 24 that have a difference of 2 would get me to 6 and 4, and negative 6 and a positive 4. Leading coefficient's 1. Factors of 10 that get me to 3, 5, and 2 needs to be a positive 5 and a negative 2. Now, because I'm multiplying now, it's like I've got one big fraction. So let's start crossing off. Plus 4, minus 2, 1x and 2 x's, which leaves me with 1x on the bottom. So I've got an x minus 6. I've got a 3. I've got an x plus 5. And I've got an x remaining. So remember, you can still check these answers. If I plug in 1, I would have a negative 15 over a 6. If I plug in 1 into the question, I'd have, let's see, negative 1, negative 25, 1, 4, negative 6, divided by, I'd have 1 plus 4, I'd have 3 minus 6. If I flip and multiply, it stays the same. This becomes negative 3 over 5. Double negative becomes positive. Let's see, I could multiply straight across. So I have a 30 and a negative 75, which, if I take a look, does reduce down. Okay, so same value. So I know I'm right. You guys, it's so worth it to check and make sure you're right. You have plenty of time, so let's check. All right, I know this has been a long video, you guys are hanging in there, but you can surely jump and fast forward and rewind to what you need some extra help on. But let's lastly talk about adding and subtracting rational expressions. So I need a common denominator. First one I gave you a common denominator. That's handy. So carry that x plus 4, that common denominator over. Then we're just going to add straight across the numerator. Combine your like terms. See if you can simplify anything. That numerator does not factor down, so that's my answer. All right, the second one though, definitely have to do a little bit of work here, right? So let's start off. I know I'm going to have to factor this. My leading coefficient is 1, so it's okay to jump. Factors of 25 that get me to 10, 5 and 5. All right, so now if I look, the left side is missing an x plus 5, so it needs an x plus 5. I need to distribute that 4. So first of all, I've got my common denominator, x plus 5, x plus 5. I'm going to show a few extra steps here. My right side didn't change. I'm subtracting. But my left side becomes a 4x plus 20. Now that I have a common denominator, I can put it all over one denominator. All right, if I'm subtracting all of this, a 4x subtract a negative 6x gets me to 10x. A 20 subtract a 10 is a 10. Look at how this looks. Let's take out a 10 and see what happens. If I divide out a 10, x plus 1, nothing cancels, so it wasn't helpful, but just keep it that way. You don't have to go back and erase it. Just keep your factored form. Again, you can check your answers on these as well. Plug in a 1, see if you get the same thing from beginning to end. All right, so thanks for sticking it out. If you have any more specific questions or ways to study options for you, okay, ask me, visit with me. You can go to the Sabre Center, seek out some specific math teacher help there. The schedule is posted on Google Classroom. Previous videos, check out this YouTube channel of mine. If you want to concentrate on one topic that you struggle with, then just watch that video again. Review notes. Okay, you've got those notes there to walk you through. Remember the rules. You've got so many examples. You could even make your own little practice test with your examples. Okay, narrow it down to the areas you need to focus and what needs your attention. Study with a partner. Oh my gosh, if you can teach this to someone else, like a parent or a friend, what a great way to know that you fully understand it. So lots of options. Let me know if you need anything. Good luck with the final. It's been a great year, and keep in touch.